Hello everybody, welcome into another lesson. So today we are going to continue using matrices to solve systems of equations. Now yesterday we talked about row-echelon form, which involved getting the leading coefficient of each row to be a 1, and then we used back substitution to solve for the variables. Well, today we're going to talk about what's called reduced row-echelon form, which is going to be more work initially, but in the end it's going to be nice because you're going to have your system of equations. I have a 2 by 2 and a 3 by 3 example. The idea is that the leading digit in each row is still going to be a 1, but in reduced row echelon form, above and below the leading coefficient, you have zeros. So what that enables you to do is get a direct result for z, y, and x without having to use back substitution. But it is more row operation intensive than just a simple row echelon form using back substitution. So let's start out with a couple 2 by 2 examples, and then we'll get into some 3 by 3s. Alright, so we have x plus 2y equals 7, and then we have 2x plus y equals 8. So here's your system, x plus 2y equals 7, 2x plus y equals 8. Well, let's convert this into an augmented matrix, of course. We'll start there. So you have 1, 2, and then 7 to the right of the augmentation line. Then you have 2, 1, and 8. Alright, so it looks like the leading digit in row 1 is already a 1. That makes life a lot easier. That already helps us. Now what I would do first, because to get this into reduced row echelon form, this digit has to become 0, this digit has to become 0, but I would actually go ahead and make sure the first digit in row 2 is a 0 first. In order to do that, we're going to have to take negative 2 times row 1 and add that to row 2. So let's go ahead and apply that transformation here. So row 1 is temporarily left alone, 1, 2, and 7. Now negative 2 plus 2 is 0. Negative 4 plus 1 is negative 3. And then, let's see, negative 14 plus 8 is negative 6. Alright, we're part of the way there. So the first digit in row 2 is a 0. But we need to make the second digit in row 1 a 0, and the leading coefficient in row 2 needs to be a 1. I'm definitely going to suggest we make the leading coefficient in row 2 a 1 first. So let's take negative 1/3 of row 2. So what's going to happen then is row 1 again is temporarily left alone, 1, 2, and 7. And then you'll have 0 and then 1 and 2. Alright, now this is in row echelon form, which if we were using back substitution, this would be good enough. That would be good for yesterday's lesson, but today we're doing reduced row echelon form. That means we need to make the second digit in row 1 a 0. So if we take negative 2 times row 2 and add that to row 1, we can make that happen. So let's see, negative 2 times 0 is 0, plus 1 is still 1. Negative 2 plus 2 is 0. Negative 4 plus 7 is 3. And then row 2 is left alone. You have 0, 1, and 2. Well, now this is in reduced row echelon form because a leading digit in each row is 1 and you have zeros above and below the leading digit. So this tells you your direct y value is 2 and then your direct x value is 3. So the solution to this system, the ordered pair that's the solution, is going to be 3, 2. So initially you're going to do more row operations to get to where you need to be, but you'll get the direct solution of your variables without having to do back substitution. Let's do another 2 by 2 example, then we'll go into some 3 by 3s. Alright, let's see. So we have 2x plus 6y is equal to 16. We have 2x plus 3y equals 7. So here's your system. 2x plus 6y equals 16. 2x plus 3y equals 7. Let's go ahead and set up our augmented matrix. So this would end up being 2, 6, 16, 2, 3, and 7. Alright, so definitely, yes, it's true you need your leading digit in row 1 to be a 1, but I would actually go ahead and use the fact that both rows have the same coefficient of 2 on the x and make your first digit in row 2 a 0. So we can just take the negative of row 1 and add it to row 2, and the first digit of row 2 will become a 0. So this would be 2, 6, 16. Negative 2 plus 2 is 0. Negative 6 plus 3 is negative 3. Negative 16 plus 7 is negative 9. Alright, so there's a couple ways you can approach this, but we're actually going to go ahead and make the leading digit of row 1 a 1. That can be done by taking half of row 1, of course. You're going to see why I went that route. Taking half of row 1 makes this 1, 3, and 8. And then you have 0, negative 3, and negative 9. So you're going to see why I did that, because I need to make the second digit of row 1 a 0. I can just directly add row 2 to row 1 and make that happen. So I'm going to add row 2 to row 1 to make the second digit of row 1 a 0. So you would have 1, 0, negative 1, and then you'll have 0, negative 3, negative 9. Now the only thing left to do is make the leading coefficient, or the leading digit of row 2 a 1. I just got to take negative 1/3 of row 2. If I decided to do that, I would end up having 1, 0, negative 1, 0, 1, and 3. So now I have a matrix in reduced row echelon form. This tells me my direct y value is 3. My direct x value is negative 1. So the ordered pair that's going to be my solution to this system is going to be negative 1, 3. So there is the ordered pair that's the solution to this system. All right. So there was some introductory 2 by 2s. Let's get into some 3 by 3s. so we have x minus 3z equals negative 2. We have 3x plus 2y. I'm sorry, 3x plus 1y. Excuse me, I want to get the system right. 3x plus y minus 2z equals 5. Negative, or just 5 rather. It's just 5, okay. And then I have 2x plus 2y plus z equals 4. So I have x minus 3z equals negative 2, 3x plus y minus 2z equals 5, and then 2x plus 2y plus 2z equals 4. Let's go ahead and set up the augmented matrix that's going to represent the system. So in the first row, you'll have 1 for your x coefficient. You'll have 0 for your y, since you don't have a y term. Negative 3 for your z. And then to the right of the augmentation line, a negative 2. Then you'll have 3, 1, negative 2, 5. Then you'll end up having 2, 2, 1, and then 4. Alright, so here's your augmented matrix. Now let's notice something here. Notice how the second digit in row 1's already a 0, and you have your leading coefficient in row 1 a 1. This is actually the perfect position to leave it be. To leave your row 1 in row 1 and not swap rows, because you're part of the way there already for having this in reduced row echelon form. So next thing I'm going to suggest is we make the first digits in rows 2 and 3 a 0. And you can do both row operations at once. If I take negative 3 times row 1, add that to row 2, and if I take negative 2 times row 1, add that to row 3, I can make those first digits in each of those rows a 0. So let's do that here. So row 1 is temporarily left alone. 1, 0, negative 3, negative 2. Alright, negative 3 plus 3 is 0. 0 plus 1 is 1. 9 minus 2 is 7. And then let's see, 6 plus 5 is 11. Alright, let's deal with row 3 now. So negative 2 plus 2 is 0. 0 plus 2 is 2. 6 plus 1 is 7. 4 plus 4 is 8. Alright, well, we have the first digits in rows 2 and 3 being 0. The next thing I'm going to highly suggest is that we make the second digit in row 3 a 0. That can be done, of course, if I take negative 2 times row 2 and add that to row 3, I can certainly accomplish that. So you'll have 1, 0, negative 3, then negative 2, and then you'll still have 0, 1, and 7, and 11. Alright, now 0 plus 0 is 0. Negative 2 plus 2 is 0. Negative 14 plus 7 is negative 7. And then let's see, negative 22 plus 8 is going to be negative 14. Alright, so now we have the first two digits in row 3 being 0. Now, it's true the leading digit in row 3 needs to be a 1, but let's notice something here. In row 2, actually, you know what? Let's make this leading digit a 1. I'm going to tell you why, because we can do two operations at once after the fact if we do that. So if I take negative 1/7 of row 3, I'll end up getting my leading digit to be a 1 in row 3. So you'll have 1, 0, negative 3, then negative 2, 0, 1, 7, 11. Alright, so negative 1/7 of 0, 0, 0 again, and then you'll have 1 and 2. So we've reduced row 3 all we can do. Now, all that's left to do, if you look here, is make the third digit of rows 2 and row 1 into a 0. So if I take 3 times row 3 and add that to row 1, I can make that last digit a 0. If I take negative 7 times row 3 and add that to row 2, I can make that last digit a 0. So let's go ahead and perform those transformations. So row 3 and row 1 together, so 0 plus 1 is still 1, 0 plus 0 is 0, 3 minus 3 is 0. Alright, 6 minus 2 is 4. So there's my row 1 transformed. Now, negative 7 times row 3 plus row 2, so 0 plus 0 is still 0. And then 0 plus 1 is going to be 1. Negative 7 plus 7 is 0. Negative 14 plus 11 is going to be negative 3. And then you have your third row, 0, 0, 1, and 2. Now I finally got a matrix in reduced row echelon form, which gives me my direct x, y, and z values. So x would equal 4, y would equal negative 3, and z would equal 2. So the ordered triple that's going to be the solution to this system is going to be 4, negative 3, and 2. So 4, negative 3, 2 ends up being the ordered triple that's the solution to this system. Alright. So we have 2x minus y plus 3z equals 24. Two y minus z equals 14. Seven x minus 5y is equal to 6. This one's a little bit messy, but that's okay. So we have 2x minus y plus 3z equals 24. 2y minus z equals 14. 7x minus 5y equals 6. Well, what I'm highly going to suggest here is that first thing, of course, we need to write this in augmented matrix form. So that would be 2, negative 1, and 3. And then, of course, 24 to the right of that dotted line. And then you'll have 0, 2, negative 1, and 14. And then you'll have 7, negative 5, 0, and 6. So we have a bit of a mess here, don't we? Well, how are we going to approach something like this? So, what I'm going to suggest here first is, if you look at rows 3 and 2, you see that the third digit of row 3 is a 0. That would definitely be suitable for me to switch rows 2 and 3. You can switch rows without changing the overall result. So let's switch rows 2 and 3. Now, evaluating these matrices doing the row operations can be taken on a case-by-case basis. You may do it a slightly different way than I do, but in the end it should end up in reduced row echelon form, and we should all get the same result. So, there's just some ways that are better than others to do this, but let's switch rows 2 and 3. So 2, negative 1, 3, 24. Alright, so this would become 7, negative 5, 0, 6, and then 0, 2, negative 1, and 14. Okay. What I'm going to suggest now is we make that first digit of row 2 a 0. If I take negative 7 times row 1 and add that to 2 times row 2, I can accomplish that. So negative 7 times 2 is negative 14 plus 4. Well, wait, I need to write out my row 1, duh. I'm jumping ahead here, forgive me. Alright, so this would turn into negative 14 plus 14 is 0. 7 minus 10 is negative 3. Negative 21 plus 0 is negative 21. Alright, negative 168 plus 12, that's going to end up being negative 156. And then you'll have your third row, which we haven't touched yet. 0, 2, negative 1, and 14. So yes, this can get a bit hairy sometimes. Alright. Now, we got our first digits in rows 2 and 3 to be a 0. Now we need to make the second digit in row 3 a 0. If I take 2 times row 2 and add that to 3 times row 3, I can accomplish that. So we'll have, let's see, 2, negative 1, whoops, I'm jumping ahead again, 3, and then 24. Alright, so we're leaving row 2 alone temporarily. 0, negative 3, negative 21, negative 156. Alright, 0 plus 0 is 0. Negative 6 plus 6 is 0. Negative 42 minus 3 is going to be negative 45. Oh boy, this is going to be a doozy, because I got to take 2 times negative 156 and add that to 42. So now add 42 to that, you get 270, negative 270, excuse me. So the third row is not pretty. It's going to be 0, 0, negative 45, negative 270. But the good news is the first digit in row 2 is a 0. The first two digits in row 3 are a 0. So if I take negative 1/45 of row 3, I can make this leading digit a 1. So let's take negative 1/45 of row 3. What's that going to turn this into? So you'll still have 2, negative 1, 3, and 24. We're leaving row 2 alone temporarily. 0, negative 3, 21, negative 156. So you'll have 0, 0, 1. And then let's see if, you know what, 45 times 3 is 135, so that'd be 6. This would end up being positive 6. All right. Well, we have row 3 fully reduced. 0, 0, 1, and 6. The leading digit's a 1, so that's good. Now, what we need to do next is make the third digits in rows 2 and 1 a 0. Let's go ahead and proceed that way. So if I take negative 3 times row 3 and I go ahead and I add that to row 1, I can accomplish that in row 1. If I take 21 times row 3 and add that to row 2, I can do that to row 2. So let's see what we get here. 0 plus 2 is still 2. 0 minus 1 is still negative 1. Alright, now this is where it turns. Negative 3 plus 3 is 0. And then negative 18 plus 24 is 6. Alright, now we're dealing with between rows 3 and 2. 0 plus 0 is still 0. 0 minus 3 is still negative 3. And then, let's see, 21 minus 21 is going to be 0. And then 21 times 6, that's 126 minus 156, that's negative 30. Then we have 0, 0, 1, and 6. Got some of these numbers down. Now, I hate to say this, but we're going to have to do some erasing. If you need to see these transformations, feel free to pause the video, especially if you're taking notes. You can pause it, rewind it, do whatever you need to do. It's just my board's only so big, I'm going to run out of room. So, I'm going to erase everything up to a certain point here. Let's erase everything above this line, and then we can... Alright, so let's look at this matrix here, okay? One thing I need to do is make my leading digit in row 2 a 1. Well, I need to take negative 1/3 of row 2. If I do that, let's apply the transformation. I'm going to come up here. Row 1 is still left alone. I'll have 2, negative 1, 0, and 6. Alright, so then I would have 0, 1, 0, 10. And then I would have 0, 0, 1, and 6. Well, now I need to make the second digit of row 1 a 0. If I just add row 2 to row 1, I can do that. So, row 2 plus row 1, this is going to turn this into, you'll still have 2, but 1 minus 1 is 0. 0 plus 0 is 0. 10 plus 6 is going to be 16. Then rows 2 and 3 are already reduced. We can leave those alone. all that's left to do now is make my leading digit of row 1 a 1. I just take half of row 1, I can do that. So let's apply that transformation. You'll end up getting 1, 0, 0, and 8, 0, 1, 0, 10, 0, 0, 1, and 16. Now I have this in reduced row echelon form. I can get the direct values of x, y, and z, where x equals 8, y equals 10, and z equals 16. So the ordered triple, that's the solution to this system, is going to be 8, 10, 16. So there's the solution, the ordered triple, 8, 10, and 16. Let's do one more. And then I think we'll call it good for the lesson. All right, let's see here. Negative x plus y minus z equals negative 14. 2x minus y plus z equals 21. 3x plus 2y plus z equals 19. Alright, so negative x plus y minus z equals negative 14. 2x minus y plus z equals 21. 3x plus 2y plus z equals 19. Let's go ahead and convert this into an augmented matrix. So you'll have negative 1, 1, negative 1, negative 14. Then you'll end up having 2, negative 1, 1, 21. Then you'll have 3, 2, 1, 19. Alright, so there's your augmented matrix. Well, good news is, even though the leading coefficient's a negative 1 in row 1, it's going to be easy to make the first digits in rows 2 and 3 a 0. All I have to do is take 2 times row 1, add that to row 2, just row 2, not 2 times that. Then if I take 3 times row 1 and add that to row 3, I can make the first digits in each of those rows a 0. So let's go ahead and apply those transformations. You'll have negative 1, 1, negative 1, and then 14. So negative 2 plus 2 is 0. 2 minus 1 is 1. Negative 2 plus 1 is negative 1. Let's see, negative 28 plus 21 is going to be negative 7. Alright, negative 3 plus 3 is 0. 3 plus 2 is 5. Negative 3 plus 1 is going to be negative 2. Negative 42 plus 19 is going to be negative 23. So we got the first digits of rows 2 and 3 to be 0. Now we need to make the second digit of row 3 a 0. If I take negative 5 times row 2 and add that to row 3, I can accomplish that. So let's do that. You'll have negative 1, 1, negative 1. and then negative 14. Let's see, then you'll end up having 0, 1, negative 1, negative 7. Alright, 0 plus 0 is still 0. Negative 5 plus 5 is 0. 5 minus 2 is 3. And then you'll end up having 35 minus 23 is 12. Okay. So we got now both of the first two digits in row 3 to be a 0. It would probably help if I made the third digit, the leading digit in row 3, a 1. I can accomplish that just by taking a third of row 3. So let's do so. You'll have negative 1, 1, negative 1, negative 14, 0, 1, negative 1, negative 7, 0, 0, 1, and 4. Alright, next thing I would actually suggest we go ahead and do is make the third digits of rows 2 and 1 a 0. Well, if I just straight up add row 3 to row 1, and then I add row 3 to row 2, I can accomplish that in both of those rows. So this would end up, let's see, row 3 and row 1, 0 minus 1, that's going to be negative 1. 0 plus 1 is 1. Alright, 1 minus 1 is 0. And then 4 minus 14 is negative 10. Now let's deal between rows 3 and 2. 0 plus 0 is also 0. 0 plus 1 is 1. 1 minus 1 is 0. 4 minus 7 is negative 3. And then we have row 3, which is already reduced. 0, 0, 1, and 4. Okay, so the next thing I'm going to suggest is we go ahead, we make the second digit in row 1 into a 0. And I'm going to have to erase some again and go upwards because I'm about to run out of room. But if you need to, pause the video and what have you to see what I've done previously here. But I can make the second digit of row 1 a 0 if I just add the negative of row 2 to row 1. So we're going to go ahead and apply that transformation once I erase some things up here and make some space. Okay, so we have, let's see, 0 minus 1 is still negative 1. Negative 1 plus 1 is 0. 0 plus 0 is still 0. Let's see, 3 minus 10 is negative 7. Then we have 0, 1, 0, negative 3. 0, 0, 1, and 4. We're almost there to reduce row echelon form. There's just one thing stopping us. We need the leading digit in row 1 to be positive 1. Well, that's a dead giveaway. If I just take the negative of row 1 and transform that, I'll have it in reduced row echelon form. So this would turn into 1, 0, 0, 7. 0, 1, 0, negative 3, 0, 0, 1, and 4. Now I have the matrix in reduced row echelon form, so I have the direct results for x, y, and z, where x equals 7, y equals negative 3, and then z equals 4. So the ordered triple that's going to be my solution is going to end up being 7, negative 3, 4. I'll end up with 7, -3, and 4 as my order triple. That's the solution to this system. So that's it for this lesson. The next lesson, we're going to kind of take a break from solving systems. We'll come back to using matrices to solve systems because, believe it or not, there's more methods than what we've talked about so far. But we're going to do addition, subtraction, and scalar multiplication of matrices in the next lesson. So I hope everyone has a great day. Take care.